Problem 1, part A, we want to show that A cross product B squared is equal to vector A squared times vector B squared minus A dot B squared. Well, let us consider that A dot B is equal to vector A times vector B cosine theta, and that A cross product B equals vector A times vector B sine theta. Well, then we know that sine squared theta plus cosine squared theta equals 1. Well, then if we add the first two assumptions or equations, we'll get that A dot B squared plus A cross product B squared equals vector A squared times vector B squared cosine theta squared plus vector A squared times vector B squared sine theta squared. Now, the reason why we're doing this is because we're adding these two equations to each other. For example, we're adding the A dot B to this part here. Likewise, we're adding the A cross product B over to this side. And so that is how we get this full equation that you see here. Well, once we simplify that, we basically get that A dot B squared plus A cross product B squared equals vector A squared times vector B squared times that by cosine theta squared plus sine theta squared. And when we simplify, we can replace that by equaling that to 1. Let me write that right here. So then our equation becomes A dot B squared plus A cross product B squared is equal to A vector A squared times vector B squared times that by 1. So essentially, because this whole one is equal to this, we essentially boil it down to A cross product B squared is equal to vector A squared times vector B squared minus A dot B. And the reason why we get that is because we were taking this section and subtracting that over here. And so that's how we get the minus A dot B squared.